Alright guys, I'm going to show you the physical prototype of the servo motor that I created last week. We're going to use the 5-volt power output, ground, and we're going to use pin 9 on the right side of the Arduino board with the tilde sign in front of it, which allows the pulse width modulation to go back and forth. We're turning a digital signal into a analog signal by turning the switch on and off thousands of times per second, so we're able to achieve an angle on the servo, and so that's what's going on. So the reset switch on this Arduino Uno board allows you to provide input to shut off and on the program. It's not in the program, but it allows you to provide input to shut the circuit off if you want to shut it off in case of emergency. If there's want to shut it down because the motor is hitting something or fell off or something like that. So you need a automatic shutdown switch, and this shuts the entire thing down. And then I think Thursday we wrote a program that provided input and output for the push button switch and the light, but that was just a straight digital circuit. So let's play the video from last week. And so basically, most servos have a standard hookup. You have your power, ground, and signal on those 3 pins at the top of the servo, and that controls the flow of the program and the current through the motor, and it tells the Arduino motor what to do. Alright, so there's my ground. Just a little recap from last week. Color coding is highly recommended. There's my power going into 5 volts, red. And I like 90-degree angles in my setup. Alright, and then your signal. Your signal is going to be going into your Arduino. This is what we did last week. It's just kind of a recap. And in this case, our servo that we're going to use, I believe, used orange for their signal wire, and so we're going to do the same thing. Alright, so I know why. That's why I used. That's not quite orange. That's more gold. But anyway, so you got to hook up your ground going back into the Arduino Uno board. Got your power going in. Got your signal going in. And just a recap on our code. Throw that away, and I wish I could speed this up a little bit, but this is pre-recorded from last week. So basically, we're going to count up and count down. If you remember, we have to set our pin to 0. 0 could be any which way that servo is positioned on your robot. It could be vertical, horizontal, diagonal. It all depends on how your claw or your lifting mechanism is situated on the robot. And remember, the loops we're creating are reading off pin 9. Pin 9 is the pulse width modulation pin with the tilde in front of it, and that allows us, again, to convert a digital signal to an analog, which goes into the servo. And so we set our position. The variable is our position 0. We define that, and it doesn't have to be straight up and down. It can be any direction. All right, so I have to set our position back to 0 each time. So we're going to count up on the first count and count down on the second. And they're going to both make sure you read both off pin 9, or it's not going to compile. And it's going to count up to 90 and down from 90. So basically, it's going to go backwards and forwards. So once all this is created, oh yeah, you got to put your wait blocks in there. 40 milliseconds is way too long. I would put in 25 milliseconds on each count up and count down. For the tiny servo we're using, 40 seconds is too long. So 25 milliseconds, you're going to see it here in a few seconds. It's going to basically go like that and back again. Tinkercad does not go dead center on the return, and I'm not sure why. But my physical prototype does. So I don't know why Tinkercad does that. So now we're going to go to the blocks and text. Basically, when you copy this into your Arduino sketch, just a review from last week, Servo 9 is pin 9. There's your set servo to 0 position. And then below that is the count up and count down. So when you copy and paste all this code into your Arduino sketch, you're going to see here in a few seconds how I plugged it in and uploaded it. Compile it first, and then you're going to run it from your Arduino sketch. Once again, the link to download Arduino sketch, it's free. I'll provide that on my website. So, and then this is see, last week we put in the oscilloscope, which is we're going to cut the video off from here, and we're going to cut straight into the physical prototype that we just created. I just created, and I'm going to show you that real quick. So let's see, where's that? There it is. All right, so you got your Arduino board, and the plastic below it prevents static electricity charge coming up anywhere through carpet. You want to make sure that you keep that Arduino board safe from static electricity. I've got my ground set up. There's my little tiny servo, and you can see I got this on a 25 millisecond loop, counting up and counting down. And you got the 3 wires going up the top, and it's gold, I guess, goldish orange, the signal wire. There's my power button, and I'm interrupting the program coming from the laptop. The light turns off, blinks, and it starts over again. So basically, you got to make sure that you properly ground everything. You make sure that you, first of all, do not walk across the carpet and pick your Arduino Uno board up without properly discharging. There's all kinds of precautions you need to make sure that you do, because this Arduino board is not foolproof. Meaning you can actually short this thing out, and there goes about 18 bucks. So these relatively cheap, but at the same time, you want to maintain your equipment, and you want to make sure you're properly ground every time you touch this board, and that's what I've done here. Do not plug this into your laptop unless you have the ground hooked up before you plug it in. Otherwise, you're just you're jeopardizing the circuit. So anyway, there it is, and pretty simple, straightforward, a lot of fun. Hope to get some of these kits in my classroom next year. I'm going to put in the donors choose, and if parents want to help out, I need about 10 of these kits per for a class set for next year. So I'm going to put, you're going to see something like this in donors choose, and if your parents want to help out, that'd be great. Thank you.